They called it an alien visitation. It has drifted through the darkness for 7 billion years, cold, invisible, like a ghost searching for its way home. Science calls it astronomy, but NASA calls it a terrifying anomaly. Because in a place where there should only be death and ice, it carries the most precious code of life. It does not obey gravity. It does not follow the laws of the stars. It slithered into our solar system with a precision so absolute, it could not be an accident. When the veil of night was torn away, scientists realized in horror, this was not a discovery. This was an intrusion. 3I/Atlas. On the night of July 1st, 2025, the night watchers at the Atlas survey station in Chile, the dedicated teams who spend their careers scanning the darkness for moving objects, spotted something that made them look twice. It was moving too fast. Not fast the way a comet from the outer solar system moves, but fast in the way a bullet moves, the way something moves when it has been traveling for a very long time through a place with no friction and no resistance. The object was clocking 58 kilometers per second, still outside the orbit of Jupiter, still so far away that most telescopes could only see it as a faint and hurrying smear of light. The velocity alone confirmed what the night watchers already suspected. This object was not bound to our sun. It was moving on a hyperbolic trajectory, an open-ended path that enters our solar system from the void between stars and exits back into that void without ever slowing down enough for gravity to catch it. The third interstellar visitor ever detected. Its name, 3I/Atlas. The astrophysicists who traced 3I/Atlas backward through its trajectory found its origin not in the thin disk of our galaxy, where young stars burn bright, but in the thick disk, the ancient region that floats above and below the galaxy's main plane, where stars are old and objects have been drifting since long before our sun existed. The age estimate runs as high as 7.6 billion years. Our entire solar system is only 4.6 billion years old. This object existed in the darkness for more than 3 billion years before our planet was even a thought, threading past 93 different star systems over just the last 10 million years of its journey. Now, here is the part about geometry. Pay close attention, because this is the detail that made the people at Johnson Space Center stop mid-sentence when they first heard it. When Oumuamua arrived in 2017, it came at us roughly head-on from the direction our solar system is moving. When Borisov arrived in 2019, it came in at a steep diagonal from the northern sky. Both fit within trajectories a naturally drifting object might take. But 3I/Atlas came at us from the side, a T-bone collision if our solar system were a car in an intersection. And here is the thing that is a very big coincidence. It is aligned with the plane of our solar system's ecliptic to within 3 degrees. In three-dimensional space, where an incoming object could approach from any angle in a full sphere of possible directions, this one skimmed in almost perfectly parallel with the flat disk of our planetary orbits. The analysts at the Jet Propulsion Laboratory ran the probability calculations. The teams at the European Space Agency ran them independently. It is aligned. What we do not yet know is why. Let us talk about chemistry, because this is where 3I/Atlas truly stops making sense. In late September 2025, a team led by Zexi Xing, a postdoctoral researcher at Auburn University, published findings in the astrophysical journal Letters that circulated through the planetary science community like a shockwave. Using NASA's Neil Gehrels Swift Observatory, a space-based telescope orbiting above Earth's atmosphere, capable of observing in ultraviolet wavelengths that ground-based instruments cannot reach. The Auburn team detected hydroxyl gas emanating from 3I/Atlas. Hydroxyl is the chemical fingerprint of water. It is what you get when sunlight breaks a water molecule apart, and the faint UV glow it produces is exactly what Swift was built to see. This meant one undeniable thing. 3I/Atlas was actively releasing water vapor into space in enormous quantities. Here is why that broke every model we had. At the time of detection, 3I/Atlas was nearly 3 astronomical units from the Sun, 3 times the Earth-Sun distance, out in the cold region of the asteroid belt, where sunlight is far too weak to sublimate water ice into gas. In every comet studied from our own solar system, meaningful water activity does not begin until between 1 and 2 astronomical units from the Sun. At 3 astronomical units, the water should be locked, sleeping. But 3I/Atlas was releasing water at approximately 40 kilograms per second, the equivalent of a fire hose at full blast, at a distance where our sun's heat simply should not be capable of causing it. As Xing himself said, every interstellar object has rewritten what we thought we knew. Oumuamua was dry. Borisov was rich in carbon monoxide, and Atlas is releasing water at distances and rates that fit no existing model of comet behavior in our solar system. That unease deepens when you consider the metallic chemistry. The spectroscopic analysis teams working across observatories from Chile to the Canary Islands found nickel in the coma of 3I/Atlas, but could not find iron. In the natural universe, nickel and iron are inseparable, forged in the same dying stellar cores, scattered by the same supernovae, incorporated into every rocky body through the same cosmic process. They always travel together. And yet, in the early coma of 3I/Atlas, the iron was absent in a way that no naturally formed body should produce. It was only as perihelion approached that iron began appearing, and the ratio gradually normalized, as if whatever process had separated them was only now releasing its grip. And then 3I/Atlas accelerated beyond what gravity alone could account for. The European Space Agency's ExoMars Trace Gas Orbiter, which turned its instruments toward 3I/Atlas as the object passed within 0.19 astronomical units of Mars on October the 3rd, its closest planetary encounter, recorded up to 7 distinct jets of material firing from the nucleus, structured and directional, powerful enough to produce a sun-facing tail that violated the basic physics of how solar wind shapes a comet's visible structure. The tail eventually corrected, but that image remained in the data, one more entry on a list of anomalies that had, by this point, become very long indeed. Here is what we are left with. An object older than our world by 3 billion years. A trajectory aligned with our orbital plane to a precision that defies random probability. Water vapor erupts where it should be frozen solid. A metallic chemistry that separates elements by nature does not separate. 7 organized jets firing from the nucleus as it rounds our star. Every observation in isolation might be explained by some exotic natural process we have not yet catalogued. Together, they form a pattern so consistently surprising it feels less like a gap in knowledge and more like a message written in a language we have not yet learned to pass. We will see 3I/Atlas one final time. In March of 2026, the Juno spacecraft orbiting Jupiter will capture one last image before the object exits our solar system forever, carrying its 7.6 billion years of memory into a silence we cannot follow. But what it leaves behind is worth more than any answer it might have given. It leaves behind the sharpest possible reminder that the universe is older and stranger than any civilization's models can fully contain. The night watchers in Chile who first clocked that suspicious velocity. The post-doctoral researchers at Auburn who coaxed Walter's fingerprint from ultraviolet data. The engineers at Goddard who spent sleepless nights cross-checking jets and trajectories and missing iron. These people represent the best of what we are, a species that looks at the incomprehensible and leans in closer rather than looking away. Space is hard, the cosmos is ancient, and every anomaly is an invitation. We have never, in all our long history, been the kind of species to turn one down. Keep looking up.